let us discuss quadratic equations concept first. What is the general quadratic equation? Standard quadratic equation is ax square plus bx plus c is equal to 0, where a, b, c are either real numbers or complex numbers such that a should not be 0. Then this is said to be a standard quadratic equation whose roots are given by x is equal to minus b plus or minus under root b square minus 4ac by 2a. These are the roots. And the term b square minus 4ac, this value is known as discriminant denoted by delta. So find the discriminant of the quadratic equation means you have to find b square minus 4ac. And we know that sum of roots of quadratic equation, suppose if alpha and beta are the roots, sum of roots is minus b by a, product of roots is c by a, and the difference between the roots under root b square minus 4ac by mod a. That b square minus 4ac is nothing but delta. So root delta by mod a. See, discriminant is denoted with either delta or with the capital letter D. Both are same. Both represents discriminant. So sum of roots is minus b by a, product of roots is c by a, difference between the roots is under root b square minus 4ac by mod a. So when equation is given, this is the formula for finding roots. Then when roots are given, what is the formula for finding equation? That is the equation whose roots are alpha and beta is x square minus alpha plus beta into x plus alpha beta is equal to 0. This can be remembered as x square minus sum of the roots into x plus product of the roots is equal to 0. So what is the formula for finding quadratic equation when roots are known? X square minus sum of the roots into x plus product of the roots is equal to 0. Next, nature of the roots of a quadratic equation. Nature of the roots of quadratic equation depends upon the discriminant delta is equal to b square minus 4ac. First case, let us say ABC are real numbers. ABC are real numbers. If delta is greater than 0, then the roots are real and distinct. If delta is equal to 0, then the roots are real and equal. If delta is less than 0, then the roots are imaginary. That is, if one root is p plus iq, then the other root will be conjugate of that. And complex numbers always occurs as conjugate pairs. So if p plus iq is one of the root, then the other root will be p minus iq, where I is equal to root of minus 1. So remember, nature of the roots of quadratic equation depends upon the discriminant. First case is if a, b, c are real numbers, and if delta is greater than 0, roots are real and distinct. If delta is equal to 0, roots are real and equal. If delta is less than 0, roots are imaginary. And how those imaginary roots will be? If one root is p plus iq, the other root will be conjugate of it, p minus iq. Next, second case is if a, b, c are rational numbers, then how the nature of the roots? Again, it depends upon discriminant delta. If delta is a perfect square, then the roots are rational. If one root is p plus root q, then other root will be p minus root q, which are known as conjugate surds. P plus root q and p minus root q are known as conjugate surds. So if one root is p plus root q, then the other root will be p minus root q. Next, what are the conditions for common roots? These are the two quadratic equations. Let us say alpha is the common root for these two quadratic equations. Common root means the root which satisfies both the equations. The condition for common root should be remembered like this. This is the condition for common roots. CA dash, this is the condition for one root to be common for both the quadratic equations. CA dash minus C dash A whole square is equal to AB dash minus A dash going to BC dash minus B dash. This is the condition for common root, and this is the formula for finding the common root alpha. You can use either of these two, either this or this. For finding common root, this is the condition for common root. Now, this is the condition for both roots to be common. This is the condition for both roots to be common. that is a by a dash is equal to b by b dash is equal to c by c dash is a condition for two roots to be common. Roots under particular cases. Suppose for this quadratic equation, if b is 0, then the roots are of equal magnitude and opposite in sign. For example, if roots are alpha and minus alpha, here we say that roots are equal in magnitude but opposite in sign. Then what is sum of roots? 0. Sum of roots is minus b by a, which is 0. From this you get b is equal to 0. So b is equal to 0 means roots are of equal in magnitude and opposite in sign. Next, if c is equal to 0, then what is the quadratic equation? This is a quadratic equation. Take x common. Then what are the two roots? 0 is one root, minus b by a is another root. So if c is equal to 0, what are the two roots means? 0 and minus b by a. Next, if a and c are equal, then the roots are reciprocal to each other. What is the formula for product of roots? C by a. If roots are reciprocal to each other, then one root is alpha, other root is 1 by alpha, which is c by a. Which means 1 is equal to c by a or a is equal to c. So if a and c are equal, all the roots will be alpha and 1 by alpha, which means reciprocal to each other. Next, what is product of the root? C by a. Suppose if out of a and c, if one is positive, other is negative, then product of the roots will be negative. If a is positive and c is negative, or if a is negative, c is positive, product of roots will be negative. Product of roots negative means roots are of opposite signs. So roots are of opposite signs implies if one is positive, other root is negative, then product will be negative. C by a negative means one is positive, other is negative. These are not required. Look at the last one. If a plus b plus c is 0, when you get a plus b plus c are 0 when x is 1. So one root is 1. What is product of the, let us say other root is beta. What is product of the root? C by a. So 1 into beta c by a. So beta is equal to c by a. So what is other root? C by a. This is very important. If sum of all the coefficients is 0, then the roots are 1 and c by a. When you get a plus b plus c are 0 when x is 1. Let us say the other root is beta. Product of roots 1 into beta c by a. So beta c by a. So what are the two roots if a plus b plus c is 0 means 1 and c by a. Next, maximum and minimum values of the quadratic expression. So whether the expression has maximum or minimum value depends upon the x square coefficient a. If a is positive, it will have minimum value. If a is negative, if a is positive, it will have minimum value. If a is negative, it will have maximum value. And the formula for that is 4ac minus b square by 4a. B square minus 4ac is delta, so this is minus delta, so minus delta by 4a. We also get the same value. And that maximum or minimum value occurs at x is equal to minus b. So for a quadratic expression, maximum minimum value depends upon x square coefficient a. If a is positive, it will have minimum value. If a is negative, it will have maximum value. And the formula for that maximum or minimum value is minus delta by 4a. And at what value of x that minimum value occurs or maximum value occurs means that x is equal to minus b by 2a. Next, location of the roots. You need to remember these results. Conditions for both the roots to be greater than a specified number d. Suppose let us say both the roots are greater than some 5 or some number will be given. Then what are the conditions for that? both the numbers are greater than the specific number means delta can be either greater than or equal to 0, a into f of d greater than 0 and minus b by 2 greater than d. Look at these diagrams. And these are the conditions for both roots to be on either side of the number d. Suppose if given number d is 5, the condition for one root to be less than 5, other root to be more than 5 is, these are the conditions. A into f of d less than 0. And this is the condition for exactly one root to lie in a particular interval. And this is the condition for both the roots to lie in a particular interval. Condition for exactly one root to lie between in an interval. And the second one is condition for both roots to be in between the given interval.